All right, cool. Hey everyone. Interesting enough, I know that we went over a couple of the gateway updates, which is great. And today we're going to be going over kind of why the gateway server, what is the gateway server, and going more deeper into kind of like a technical perspective of how the gateway server works under the hood and the various things that it's taking care of for you. But before we kind of go into that, I do want to talk about like why we developed the gateway server in the first place and why it's useful. And so kind of going into kind of like the problem statement here is that Pocket can really only be leveraged by those who are well informed about the protocol. Not saying that it can't be used by others, but whenever you really think about it, there's just so much things that happens within a protocol, right? It's not as simple as tapping into a simple HTTP endpoint because Pocket is a blockchain. And so you have to think about things like grabbing a session, signing a relay and providing a proof for it, and then as well like hashing your relay and then sending that to a network. It's not intuitive. It's really, unless you spend a lot of time studying about the protocol, it will take you some time to actually send a request over to the network. And we wanted to make that easier for people to use. And so, also just kind of looking at like the existing solutions right now and kind of like simplifying that and reducing the frictions that you could use the Pocket SDK. There's Pocket Go, there's Pocket JS, and there's pros and cons to it. One of the pros is that you don't have to go through a gateway at all. You don't have to go through Grove. You don't have to go through Nodis. You could just directly use the Pocket SDK and go directly into the protocol. The problem with that is, it requires for you to still write some code as a developer. And so thinking like from a persona, let's just say I'm a blockchain exchange and I want to grab the latest Ethereum block. Most people would just use like Web3.js, Web3 Python library, plug in an inferior endpoint, and that's it. Whenever you use the Pocket SDK, given that it's a blockchain, it's not that intuitive. You have to import the Pocket SDKs, write some custom code, and still it would take you some time to actually get integrated with Pocket. And so, we didn't really see that being adopted, but as well, given that apps are permission right now, it's not really an option, but hopefully in Shannon, it will be an option. And then the other way is through the gateway approach. Pros of that is you get an easy endpoint. You go to Grove, you go to Nodis, you go to Liquify, Porters, and you just grab an endpoint. Cons of that is it's a little bit more centralized because you're still technically going through a centralized entity. And at the time, whenever the gateway server wasn't developed, there was only one gateway at the time, which was Grove, right? And so it wasn't ideal. And ultimately, that kind of led us into combining kind of like the pros and cons of both using the SDK and going through a singular gateway to develop the Pocket gateway server. Effectively, this is what allows us to grow into multiple gateways and potentially even light gateways. And I'll go into that in a little bit. So yeah, what is actually the gateway server? It's a lightweight web server that abstracts away the complexities of the protocol. And as well, it adds on a lot of enhancements to the protocol as well, such as quality of service checks, and provides you this simple HTTP endpoint that you could use to send a request over to the network. And so it provides a very development-friendly user interface and tooling that you could use to send over a request to the network. Kind of going into kind of like the use cases of the gateway server. We already touched on this, but B2B gateways under the hood can use the gateway server, and they are using the gateway server under the hood. As far as I know, Nodis, Liquify, Porters, and future gateway operators are going to be using the gateway server under the hood. And right now, like dApps, startups, just like people who just want to connect to the blockchain, they can't use the gateway server because apps are permission. However, in the Shannon update, I also envision that these small developers, instead of syncing up a full blockchain state, trying to load up a full Ethereum node that takes 600 gigabytes, terabytes of data, they could literally just stake in an application in Shannon and spin up the gateway server, and boom, right off the bat, you have access to the Ethereum chain and 50 other chains that you could tap into. And that's extremely powerful. And so let's go into a little bit more of kind of like the steps it currently takes to send a relay to the network. It's honestly really complex. A lot of these terminologies are specific to Pocket, and that's why I say that without using the SDK or without using a gateway or using the gateway server, it's really tough to kind of tap into the network, right? AATs is something that most developers wouldn't know about, and all these steps from 2 to 6, like dispatching and retrieving a session. Unless you're very familiar with Pocket terminology, these are things that aren't really easily consumable, especially if you're just used to a endpoint, right? And so that's what the gateway server under the hood kind of abstracts away from you as well. I won't go into too much of the details here on how to actually send a relay to a network. It's a little bit too protocol specific, and it can change whenever you go over to Shannon. But my point being is that the gateway server does all this for you and a lot more. And so kind of going into the enhancements that the gateway server also does is that it provides a simple HTTP endpoint that you can use to send a request. It does a lot of session management under the hood for you as well, such as like grabbing a session from a full node. It does quality of service checks. It provides you metrics, Prometheus metrics, and as well an endpoint for you to see the latency of your requests. And it has a lot of optimizations to reduce the CPU loads that it takes to run the gateway server, and as well scale to millions and billions of requests at a single time. And so we're going to go through each one of these 1 through 6 and talk a little bit more deeper in depth on how it works. The first one is a little bit simple. This is once you spin up the gateway server, there's an endpoint/relay, and you provide the chain ID. From there, once you provide the chain ID with your payload, immediately you're connected to the Pocket network, and you will receive a response from one of the node operators. And this effectively provides you the simple endpoint that you would normally get from Infera, and as well be able to tap into a lot of other blockchains that the protocol supports. But the benefit here, in my opinion, is that you don't have to spend that much compute resources or storage resources to be able to leverage the gateway server, because you're effectively delegating that over to Pocket Network's node operators. So yeah, simple endpoint to tap into Pocket Network with a simple Docker Compose file. So whenever you send a relay to the network, there's a lot of things that are actually happening under the hood whenever you use the gateway server. One of those things is called session management. Inside the code base, we call it a session registry. And what it does is that it's responsible for grabbing all the sessions within the network for each app stake and chain that you're staked into. So behind the scenes, what it would do, it was pull a full node, or what we call a dispatcher, and retrieve all the sessions and caches them. Without a session, you can't send a relay to the network. And so what we're doing is we're pretty much just like prematurely retrieving all the sessions in hand, so that way we could send a request to the network really fast. And what this does is that instead of like whenever a user sends a request to the gateway server, we don't have to send a request to the Pocket node and then get back a session and then finally send an actual request to the Pocket node again. Basically what we're doing is we're removing a round trip from the gateway server, and that ultimately reduces the latency whenever serving a request. And so yeah, effectively what we're basically doing is just caching sessions. And whenever we cache a session, this allows us to also do quality of service checks. And so kind of going into the node selector service, which is also another component inside the gateway server. Node selector service, literally what it sounds like, is responsible for determining which node is the right node to send a request to. And the way it determines which node should be sent the request is that it's constantly doing quality of service checks under the hood asynchronously. It's doing them nonstop. You have all these nodes within a session for all the apps that you're staked into, all the chains that you're staked into. And under the hood, we're constantly doing quality service checks for each one of those nodes to determine if they're healthy or not. And the way that we do quality of service checks is through this idea of a check job. It's an extendable framework to create quality of service checks for nodes. So, the idea was that we wanted to make it so that way you can easily create your own custom checks, create your own custom ways to determine if a node is healthy or not. Because at the end of the day, like determining if a node is healthy is going to be dependent on the gateway operator. Maybe they have like very strict quality of service requirements, or maybe they're trying to support a chain that doesn't really support to a specific like standard, and so they want to have like a custom integration. And so that's the use case of this check job frameworks, that you're able to extend and create more quality of service checks within the code base. And as is right now, we have two existing check jobs. One is for height checks, and the other one is for data integrity checks. We'll go over the height check. Once again, it sounds exactly what it is. The purpose of it is to determine if a node is synced or not. We don't want to send a request over to a node that isn't synced, right? That would just create really bad user experience. And so what we do during a height check job is that effectively what we do is we retrieve all the nodes' height by sending them a request for the height. And then what we'll do is we'll compare them to each other. Say, hey, what is the difference between node 1 and node 2, and node 3 and node 4? And then, if you are exceeding a specific tolerance, so, let's just say that node 1 is 10 blocks synced behind node 2, then, if the block tolerance is set at 10, then that node will no longer be sent requests. Going over to data integrity checks, this is just a check that we put in place just in case there are malicious node operators. As far as we know, this check hasn't really been used that much. To be honest, Pocket Network usually only has good node operators, not necessarily any malicious node operators that are trying to intentionally send wrong data to the user. But what this check does under the hood is that it's going to sample different nodes and determine if they're sending us a wrong block identifier. So like a block identifier can be things that you can't really guess unless you actually have the block data. So like block hash, the number of transactions inside a block, those are the two ones that we currently use. And so what we'll do is we'll take a healthy node. Step one is we'll take a healthy node, get and send them a request for a random block, and we'll use that as kind of like the source of truth. And then we'll check, like for example, if they return us a block hash of 123, we'll send that same request to 10 other node operators. And if they return us a different block hash, then we know that they're malicious. And we'll filter out those node operators as well. And ultimately, combining these two checks, what we get is that we know that whenever we do send a request over to the gateway server, you have nodes that are in synced and they're returning data because they're actually synced to the blockchain, and they're not returning data from a different blockchain or just random data to us.
Do you use to check response times?
We store the response times, and so we calculate P90 latency for the response times as well. And I'll go over that in just a second, but there shouldn't be two of them. Sorry about that. Kind of going more into filter checks. This is just kind of like, what else can we incorporate into the gateway server in the future? And, this is open arms for the community to also contribute to this open source project. Number one, you could take the check job framework and extend it to archival checks. Maybe you come up with an opinionated mechanism to query like the first 10 blocks of a node. If it returns an error, then you could punish them. And another thing is that right now the gateway server supports pretty much all the EVM chains that conform to the EVM spec. And we also added custom integration to Solana, Pocket. Near, as far as I know, is under development by Liquify. But some of these chains don't have a specification, and so they do require a little bit more special integration. But the check job framework will allow you to extend it to other chains as well. Cool. So kind of like combining this all together with a diagram here. Probably starting here with the session primer. This has always happened behind the scenes, whether you're receiving a request or not. The session primer, the session registry is responsible for just retrieving all the sessions for all your app stakes and chains and caching them. And then it feeds it over to the node selection service. The node selection service is once again responsible for determining the healthy node. It periodically runs check jobs at a certain interval. Those are changeable with by adjusting the variables. And then whenever you actually send a request over to the network, pretty much at that point, All these things happening with the node selection service and session primers happen asynchronously. And by the time you actually send a request over to the gateway server, we already have a healthy node for you. Some other cool features and enhancements of the gateway server is that we have Prometheus metrics that has everything in regards to latency. How much does it take to send a request? Is it going over to Ultras? With an environment variable, you can also visualize the service domain that, for each one of these requests. And that opens up to a lot of cool dashboards that can be created with Grafana and other observability tools. We also have an endpoint that is returned in JSON. It basically returns all sorts of data that can be used by third-party providers like PocketScan. What it does is it provides data about the node, it's the specific node, and as well, is the node synced? Is it healthy? The P90 latency, the last known height, all this cool stuff to really build out a rich data. And I said this before, but if gateway operators adopt the gateway server, this creates now a standard for quality of service data. And then third-party providers can ultimately provide data within their UX to provide rich data to node operators to help improve their quality of service. And so I know for sure PocketScan is currently working on integrating this endpoint into their tooling and then bringing back the geotab. I don't have an estimate on the timeline there, but that's kind of like the potential of this standard for quality of service data. Cool. Some other optimizations that we do under the hood, and this is just general software engineering. Whenever you're working at web requests at scale, you have to think about things like how to do connection pooling, how long to keep a connection open for, JSON deserialization and serialization. Those things take up CPU cycles, and we use these really high scale frameworks and optimal performant libraries that allow us to scale significantly. Those being Fast HTTP is actually built by the same developer or development team. And, like I said before, this allowed us to run gateway server in terms of infrastructure costs, and we can scale up to billions of requests at less than $1,000 a month. And so, ultimately this is inherited by the other gateway operators as well. But yeah, that's pretty much the end. I really meant for the questions to be asked at the end, but call to action here is that it's open source. If you're interested in spinning up a gateway, interested in improving the user experience, interested in taking up one of the existing GitHub issues, please do feel free to kind of like clone up the repository. Inside the README, we have contribution guidelines that you can use. But yeah, love to have you guys onboarded, contributing to the GitHub. Right now, there has been various contributions already from different third parties. I know Liquify, once again, is working on near implementation. ChainStack also included a PR that we merged in. I think even maybe Porters or Developer DAO even made a contribution. But yeah, this thing is just going to keep on growing and growing. And with that being said, this is a good time to ask questions now.
How are we going to deal with kind of being monotonic in terms of ensuring that we're always getting latest data? I know we're doing quality of service health checks on block height, but are they granular enough to ensure that we're always hitting the highest node?
Yes. So I mean, I kind of like hand waved it a little bit for you, but within a certain degree, we do have certainty of determining if they're like on the highest check or not. Basically, the more app stakes you have, the more nodes that you will have as well to check against. And we don't do height checks. All the check jobs are not done amongst a specific session. So it's not only set within like 24 nodes. It's actually, if you have like 10 app stakes, that's actually 240 nodes that you're checking against. And so that provides a little bit more higher guarantee that you're receiving the latest height. But as well, we do some advanced filtering by calculating the z-score. Like we're calculating the z-score to determine, like, for example, if there's like an anonymous node that returns a node height of like 4 billion, then we'll filter those out. And so these opinionated check jobs isn't going to provide 100% guarantees, right? But it actually does a pretty damn good enough job to provide a good user experience.
Question number one, with regard to more specifically, a few days ago, I posted on Discord asking why the gateway server didn't use Pocket Go, which abstracts complexities and details like signing and sending a relay. And I understand there's different ways to go about it, but was hoping you could shed a bit more light about the history and approach that led to this.
I could go into kind of like a lot more historical information on the way we went about it. I think it was a little bit of knowledge sharing as well, right? Pocket Go handles a lot of the protocol integration for you already in regards to sign-in, like you mentioned, in hashing. However, it's also built to be a general purpose library. And so it has a lot more functions than what we needed to send a relay. Because it has things, for example, submitting a transaction to the network as well for all sorts of different transaction messages. But another reason why, and it ultimately goes down to kind of like the underlying implementation, is that it uses the default HTTP client, standard library inside Golang. And, there's nothing necessarily wrong with it, but it does require a lot of fine tuning as well to really serve a lot of requests a second. For example, you have to tune like how many connections do you want to keep open within the HTTP client, and a lot of other things that fast HTTP client does for you. And so it was a little bit of assumption that probably whenever Pocket Go was built, the defaults wasn't enough for us. At the same time, I think it was good for us to also provide our own Pocket Go client, so that way there's multiple implementations, and we knew exactly how the Pocket protocol actually worked under the hood and solidified that as well.
Cool, appreciate that. And I think that actually, thank you for the answer, kind of what I was looking for. And I think this leads me well into my next question, where as we build towards Canon, where a lot of these details that you're talking about are going to be different. For example, things like signing relays, the approach and logic there is different for scalability reasons. But then there's going to be a lot of overlap on things like session management, for example, right? So some things are the same, some things are different. What would you need for a simpler integration with Canon testnet in the shorter term? And before you answer that, I think there's an SDK, right, which kind of handles state, handles network connections, handles all of those components. And then there's something that can be a library, which are just stateless functions that you can use for this core business logic. And the question is, what would be the path of least resistance to an integration with Gateway Server in the 1 to 6 week timeline?
Good question. So if I'm understanding correctly, the question is like, what would enable us to support Shannon faster, basically within the Gateway Server? What tooling would be best used for that? Whenever we developed the Gateway Server, we actually did use Pocket Go as kind of like a reference as well to see how things worked. We kind of like reverse engineered the underlying implementation of Pocket Go. And while we didn't use it directly, it was still very good learning resource for us to see exactly how things worked as well. And so probably the best thing to provide to us as like people that are building on top of the protocol is just like reference implementations, even if it's not built for scale. Because I think that's what the Gateway Server ultimate goal is as well, from abstracting away the complexities, is to make it extremely performant and built for scale. And so as long as there's like reference implementation of like, how to sign a relay, how to grab a session, even if we don't use it directly, I know that a lot of the other parts of the community definitely would use the SDK, but we would still ultimately use it as well, right? Maybe not directly, but kind of digging into it, I think a SDK would be extremely useful, especially if that SDK had like examples inside its README on how to send a relay. Yeah, to summarize that, I think from the protocol perspective, a SDK would be the best thing for us.
Awesome. Thank you for the answer.
Yeah, I have one if you have time. About the replication of the service, because I saw and hear all your explanation, but look like the process is calling the nodes to get the information, also to get the session. But what if I replicate the gateway server multiple times? I will be calling 2, 3, or n times for the same, or is
Yeah.
something in between that you will use as a cache layer?
Yeah. So currently right now, yes, everything is stored locally, meaning that it's local to the process. And to be honest, this was intentional design, and I'll go into the reasons why it's intentional design, but as well how we could also improve it. So it's intentional, right? Because people would place these gateway servers in multiple geographic regions. And so, it kind of gets into this weird situation where, because currently right now, Morse is heavily tied to geographic regions, right? Node operators are placing geographic nodes everywhere using GeoMesh. And so, depending on where you place the gateway server, the data, the quality of service data that you're getting is going to be different. And so that's why we decided to keep it local into the gateway server. The trade-off there is that for each region that you deploy the gateway server, you spend, for example, 3 gateway servers in a single region, then yeah, you're not sharing that quality of service data per region. But we're only priming the nodes periodically, and so it's not a lot of relays per session that we're sending over, right? It's like 1 or 2. There's a cooldown period, and so it's not really an issue right now. However, if we do start to send a lot of relays to the network just for quality of service checks, then I think a future improvement that we can do is that we can start to share that quality of service data per region. So, maybe a future improvement is that you have like a Redis cache that contains the quality of service data. And then, per gateway server, you can configure which Redis instance that you pull it from, and they can share it.
So, and about the RPC one, the one you will use for get the session itself, that I believe are not the network nodes, are just some nodes you place for it. What about the check for those? Do you are running some kind of check for the head to know if your dispatched are out of things or something like that?
Yeah, currently no. There is no health check to determine if the dispatcher is live. I almost wonder if it should be the responsibility of the gateway server to determine if the dispatcher is live, because to be honest, what you can do is probably use something like HA proxy and have a load balanced backend with multiple Pocket full nodes and implement an HA proxy check, and that should be sufficient. And so, I'm not opposed to it. It's just a matter of do we want to go that route and provide more responsibility for the gateway server or not? Right now, I kind of encourage people to kind of load balance to their load balanced Pocket nodes, if anything. Directly answer your question right now, no health checks. It just kind of assumes that you have a healthy dispatcher.
Yeah, I also think it's worth mentioning that with Shannon, with how dispatching works and everything like that, there might be slightly different solutions. So we also don't want to commit too heavily on features that are more specific that might, have a very short shelf life versus Shannon focused. So anyways, that's just something to keep in mind when we're thinking about features for gateway server.
Good points. All right, cool. So whenever you create an endpoint on our platform, what we now have is a toggle that says route to Pocket. And what this ultimately allows Node to do is, expand our supported blockchains, because now what we can do is basically for chains that we don't support centralized, we can just send it directly to Pocket using the gateway server. And so theoretically, let's just say that we don't support Kava Archival inside our centralized fleet. Users can still create an endpoint, and by default, it's already enabled to route to Pocket. And we could do this, for example, for Solana as well. But let's just say that there was a chain that we already support in our centralized services as well. Like, for example, Ethereum, we have a centralized node, but as well, the user has the option to route the Ethereum traffic that they created over straight to Pocket by enabling this toggle. And so it's a hybrid solution where, like, for example, we still want their business if, we don't support that blockchain node, and Pocket enables us to do that. And then in use cases where we already support the node centrally, maybe they want the benefits of Pocket Network, or they want to support Pocket Network, whatever reason, then they as well have the option to route over to Pocket. And this is hitting live end of week. And that's the update for Node East Gateway as well.